Welcome. I'm Derek Sparlin, along with fellow teammates Dakota Hobson and Javier Castro. We are the A-Team. Today, we will be presenting the System Development Lifecycle, which will be referred to as the SDLC, Analysis and Design Process, and how they correlate with project management. Let's begin. When developing information systems, there are various approaches that can be used for systems analysis and design. The traditional waterfall method, the most common approach of analysis and design, consists of 5 steps to software development. We will talk a bit more about this method soon. Object-Oriented Analysis and Design, OOAD, is an approach that combines data and methods into objects. This process is an iterative and incremental approach to systems development, sometimes referred to as a bottom-up approach. This means piecing together systems to give rise to more complex systems, thus making the original subsystems of the emergent system. Agile methodologies skip all the documentation and planning processes that other approaches have to allow fast reactions to change. Adding new facets to the development model can often confuse people. Scrum is an iterative and incremental approach to agile software development in which development teams have the ability to respond to changes by the customer quickly. A key principle in Scrum is that customers can change their mind about what they want and need at any time during a project. Adaptive software development consists of 3 steps: speculation, collaboration, and learning. During speculation, coders attempt to understand the exact nature of the software and the requirements of the users. During the collaboration phase, developers collaborate and solidify what they are doing now and how to combine their portions. During the learning phase, the newest version of software is released to users. In adaptive software development, there is never a period in which software is finished, just periods in between the newest release of the product. Scope in project development is all the work that needs to be accomplished to deliver a product, service, or result with the specified features and functions. Scope is often referred to as one of the most important phases of project management. This step provides an understanding for both you and your customer in regards to what is needed within the entire project. We all know that in order for a plan to be considered a project, it must have a beginning and an end point in sight. Lack of understanding can lead to issues with properly remaining on task, which could produce scope creep. Scope creep within project management refers to an uncontrolled changes or continuous growth in a project scope. The systems development lifecycle consists of 5 steps: planning, analysis, design, implementation, and maintenance. Now I hand it over to Dakota to explain.
The planning stage of the SDLC establishes a high-level view of the intended projects and helps determine its goals. Gantt charts and work breakdown structures are often used during this stage to develop a schedule of timelines in which deliverables need to be met. Earlier, we mentioned project scope and why it is important. The planning phase is when you determine project scope. A project charter is developed that includes the statement of scope, objectives, and participants in a project. Feasibility studies help determine whether a project is actually feasible and determine the cost and benefits of developing the new system. The analysis stage of the SDLC is when you define project goals and to define functions and operations of the intended application and analyze the end user information needs. During this stage, you will meet with the user and analyze what they want and need in the new system. You will also observe how people are using the current system. In addition to documenting the existing system, a software requirement specification is often done during this phase of the SDLC. A software requirement specification is a description that lays out all of the functional and non-functional requirements of a system. Process models are developed that track what happens during this process, takes the point of view of an external observer who looks at the way a process has been performed, and determines the improvements that must be made to make it perform more effectively or efficiently. The design stage of the SDLC describes the desired features and operations in detail. For it is within this phase that data structures are determined. A data structure is how data is organized so that it is used efficiently. Business rules are required in order to express what is wanted in the real world and what is possible through the computer environment. Oftentimes, this step in the process is most frustrating due to the amount of time that is required with the user to determine what is needed. A prototype is developed with the use of pseudocode. Pseudocode is a high-level notation that is a detailed yet readable description of what a computer program must do. The implementation stage of the SDLC is when the information obtained during the design phase comes into fruition through the use of a programming language. The byproduct of this phase is used for testing and maintenance in the last step of the process. The end user will be trained on how to properly function the system in order to ensure a productive workforce. An organizational change team will be used in order to assist in managing change and ensuring that all clients of the system or application fully accept it. The final stage of the SDLC is maintenance. The maintenance phase will continue to test the system in order to ensure that the unit functions at peak efficiency. It is within this phase that new releases for the application or system are obtained, allowing the cycle to be reintroduced into the implementation stage of the system development lifecycle. I will now allow Javier an opportunity to explain the tools that are used in the analysis and design process.
There are many tools used in the analysis and design process. These are a few, but I will primarily focus on the Unified Modeling Language, known as UMLs, Entity Relationship Diagrams, known as ERDs, and lastly, Workflow. According to UML.org, a unified modeling language is designed to provide a standard way to visualize the design of a system. The important part to note is that UML is a language for specifying and not a method or procedure. This provides a high-level view of our system in the same fashion of a blueprint for a home. Entity relationship diagrams, also known as ERDs, are slightly more explicit in terms of data flow within the system. Mike Chappell, a database expert, defines ERDs as a specialized graphic that illustrates relationships between entities in a data set. There are many ways to define a workflow, but to us, a workflow is a roadmap that answers questions based on what is needed to complete projects within a certain timeline. Gantt charts that are derived from the work breakdown structure will help us to determine our workflow, which leads us into our system building process. The A team will focus on the Scrum method of the Agile process. This would allow us to provide a more flexible means of dealing with unpredictable issues that are bound to arise, respond to inevitable change, and allow for shorter interactions which provide more feedback in order to create a better product. This directly contrasts with the steps of the waterfall method within the SDLC process. The planning process is front-loaded within the waterfall method, which sounds great in theory, but in actuality it is here that the least amount of knowledge required for the project is known. In fact, you know less about your project than you will ever know in the future. This is why we believe that the Scrum method is the better approach. We would like to thank everybody for their time and wish you all good luck in your projects.